All right, so welcome to the first of two of solving inequalities. And solving inequalities is really similar to what we did with solving equations, except for the one little detail, which I will get to when we get to that point. All right. Also, when I'm solving these inequalities, I'm also going to go ahead and work in the idea of graphing, expressing the solution in interval notation, and sometimes in set builder notation, so that we get used to all those things. All right. So first one I have here is x plus 2 is greater than or equal to 3. Okay, now in your mind, you want to think of it as x plus 2 is equal to 3. And we're going to do the exact same thing. So in order to go ahead and move the 2 over to the other side, because it's a plus 2, we have to minus 2. We're going to do the exact same thing as an inequality. So we're going to subtract 2 from both sides. This is going to cancel the 2 out on this side, leaving me with just my x. The inequality sign stays, and I have 3 minus 2, which is 1. So therefore, if I were to go ahead and graph this, I have a graph at 1. Okay, I have to shade greater than 1. So it's going to be that direction. And because it's greater than or equal to, it gets a bracket. So my interval notation is going to go from left to right. So it's going to start with my 1. It's going to go to positive infinity. And infinity always gets a set of parentheses. If I were to go ahead and express that as set builder notation, I have x is such that, and I just go ahead and plug my inequality in, x is greater than or equal to 1, and close off my braces. Pretty simple, pretty straightforward. Let's go ahead and look at the second one. Okay, the second one is x minus 4 is less than 7. Again, we're going to think of this as what we would do if it was an equality. So because I have a minus 4, I'm going to add 4 to both sides. The 4's are going to cancel out, it leaves me with x. My less than, and 7 plus 4 is 11. Which means if I were to go ahead and graph this, I have 11. X is less than 11. And because it's strictly less than, it gets a parenthesis. So my interval notation starts from the left to the right. So it starts at negative infinity. It goes to 11. Infinity or negative infinity always gets a parenthesis. The 11 has one because we graphed it that way. And set builder notation will be x is such that, we just plug in our inequality, x is less than 11. Right, let's do a few more examples of inequalities for today. Okay, so using the idea of multiplication, I have 5x is less than 15. All right, and we want to think of this one as 5x is equal to 15, which means we would divide out the 5 to solve for x, because the 5 and the x are being multiplied together. Opposite of multiplication is division. And so I would go ahead and divide both sides by 5. That will cancel out, leaving me with x is less than 15 divided by 5 is 3. And we can even test this if we really want to. So if I have a number less than 3, let's say 2. And I go ahead and plug it into my original equation. I say 5 times 2, is that less than 15? Well, 10 is less than 15, so it checks out. Right? So if we go ahead and graph this, I have 3. It has to be strictly less than. And so my interval notation will be negative infinity to 3, and the 3 also has a set of parentheses. Next example, I have 3y is greater than or equal to negative 9, right? Which means in order to solve for y, to undo multiplication, I must divide. So divide by 3. And I have y is greater than or equal to, now negative and a positive give me a negative. And 9 divided by 3 is 3. And remember, you can always check these by going ahead and placing them, the replacement values in the equation, see if it works out. My set builder for this, because it's y is such that y is greater than or equal to negative 3. If I were to graph this, I got negative 3. I misspoke, it was greater than. Greater than or equal to gets a bracket. And therefore my first number is negative 3. It goes to positive infinity. Negative 3 has a bracket. Infinity always gets a set of parentheses. And I'm done. The next example is the only time that our rules change. Okay? So in this case here, I have a negative 4x. Whenever you divide by a negative with an inequality, you must change the sign to its opposite. So this was negative 4x is less than negative 12. It must switch to greater than. Okay? And if we follow the same solving rules and divide by negative 4, that means x is greater than 3. Okay? We really should test this out to make sure we did this correctly. So I have negative 4, and x needs to be greater than 3. So let's put positive 4 in there, because it's greater than 3. And it should be less than negative 12. Well, negative times a positive is negative 16. Is it less than negative 12? It checks out. If we do not go ahead and reverse the inequality, we end up with a false statement. So we want to make sure when we divide by a negative, and this also applies to multiplication, we have to do the opposite inequality. So we have to change the inequality. And if you're unsure if your answer is correct, go ahead and reverse that, check it in, put it in your equation, see if it works out. The last example I'm going to do is something that's slightly longer. And let's go ahead and look at this. Now again, we want to look at either side of the inequality. And we want to see if each side is as simple as possible. If our answer is yes, then we go ahead and move on to solving for x. Now for inequalities, we really want our variable to be on the left, because if our variable's on the left, the inequality sign will allow us to see which side needs to be shaded. So I want to go ahead and subtract 2x from both sides on this case. That side's going to cancel. And 3x minus 2x is x. So I have x minus 7 is greater than or equal to 3. From here I'm going to add 7 to both sides. And x will be greater than or equal to 10. And so if I were to go ahead and graph this, I'd have 10 greater than or equal to gets a bracket. I'd shade to the right. Interval notation would be 10 to infinity. 10 gets a bracket, infinity gets a parentheses. set builder would be x is such that x is greater than or equal to 10. Close it with a set of braces. So go ahead and try the practice problems. If you have any issues, feel free to reach out during the class time. So we can go ahead and talk about this, and I will see you in part 2.